So who are you?
My name's Tony Donno. I'm the test manager for Virtual PC and Virtual Server.
Oh wow, cool. So we saw Ben Armstrong the other day, and he's on the same team you are on.
Yeah, Ben's the program manager. He owned Virtual PC and Virtual PC since back one.
Oh wow.
He's contributing to Virtual Server as well.
So you're a tester here, right?
Yeah, I guess you
Test
could call me
lead,
tester.
whatever.
I don't get to do too much testing myself, but I do a lot of ownership of the test stuff.
Right.
Test leads and testers who work for me.
Ah, okay. So you're more of a manager then, right?
Yes, definitely more of a manager.
And wow, how do you test a product this big? You know?
Well, that's probably one of the biggest challenges.
Because you find bugs in OS, and then your product.
Yeah, I mean, with virtualization,
you're at the mercy of a whole bunch of people, aren't you?
Yeah, with virtualization, where we're trying to emulate a whole hardware platform. We could have bugs anywhere down from hardware emulation through the operating system, through some application running on top of the operating system, or in some cases even a customer scenario where they're trying to do some particular thing and they want to involve virtualization in that process. Sky's the limit. We have everything from one end right through to the other.
What makes a good tester since you're a manager?
What makes a good tester? I would say somebody who's very creative, somebody who can think about the bigger picture and think about customer scenarios and then come up with creative ways of testing them. I mean,
when you say creative, you don't mean somebody who's good at taking photos or art.
No, somebody who can think of ways of a good example would be, take a customer scenario. A customer scenario could be very, very complex, could involve hundreds of machines, could involve very complex data structures or data systems that they're trying to use. What I need in a tester is somebody who can look at that big picture and say, well, these are the important parts. These are the parts that need to be tested. These are the technologies that whole big infrastructure relies on, and then come up with the areas that we need to focus on for testing, and then come up with ways to actually test them. Ideally in an automated way. Because the stuff is so large, trying to do manual testing across this is very time consuming.
When you're interviewing a tester, what kinds of things are you looking for when you're interviewing? I'm
looking for that creative thing. I'm looking for their ability to focus on testing. How good a tester are they? Do they have the mentality where they want to take it apart and put it back together again, find out how it works, and if it's broken, fix it. The development community focuses more on the if it's broken, fix it stuff, but the test community does that as well. I think testing is quite a big challenge. You not only need to understand what the code does, but you need to understand how you can break it.
Right.
A lot of development is done with the objective of making sure that you get it to work. A lot of testing is done with making sure that you can't break it, which puts a different slant on it.
What kind of skills do you think people coming out of school or maybe coming out of other companies lack that Microsoft needs? Or
more recently in candidates that I've interviewed and so on, or not so much interviewed, and mostly we don't end up interviewing these people for this reason, but a lot of the candidates are focused heavily on things like Java and stuff like that, and that it has a place in the marketplace, no doubt about that, but it's not the kind of stuff that I'm looking for. I'm looking for people with C knowledge, C++. There's a lot of things that I need, though, that are very difficult for people to get. Like core kernel knowledge of the Windows operating system. Where are you going to get that? So we do look a lot at internal candidates and that kind of stuff when we're looking at people. But that's not to say that that's all we need. What we really need is we need people who have a lot of potential. People who can adapt, people who can have that creative attitude, but they can adapt to different things. Having such a broad area to test, we also look for people who have fairly generic kind of knowledge rather than specific knowledge in a particular area. If you know everything about the sound device driver, well, that doesn't help me too much.
Yeah.
But if you know about device drivers in general, then you can easily switch from a network driver today, and then tomorrow you might be testing a storage device driver. That works for me. That's really useful. That's the kind of person I value.
Excellent. How does the server product compare, or how does it differ from the virtual PC desktop product?
So I don't know what Ben told you about VPC, but
Well, he gave us demo.
he was demoing
Yeah.
it. Okay. VPC is a single user application. I mean, you've got to be logged in, you've got to have it running on your desktop, and then you can run various windows and you can do stuff. The server application, the biggest distinguishing difference is the fact that the server runs as a service. So you don't need to be logged in, it can run on a remote machine, and it just runs as a service application or a service that people can connect to and have their virtual machines redirected to a remote console. That's the second most important part. Is VPC, you have to be on the machine that you're running VPC on.
Got it.
With virtual server, you don't. For example, in what I'm going to demo to you, I've got one machine, the machine on the left there, that's the machine that we're going to be using to look at my virtual machines, and then the Dell machine on the right is going to be the actual virtual server itself.
Right.
And we have a web browser interface that allows you to get to that.
Okay.
So remoting is something that's very different in virtual server. The fact that it runs as a service rather than an application. Then some of the more core differences are things like virtual PC is only uniproc aware, virtual server is multiproc aware, where you make use of all the processes in the machine, whereas VPC won't. We have
That's interesting because there's more multi-core. Does it make use of the multi-core processors?
multi-core processors as they become more mainstream. Yes, definitely we'll be making use of that stuff.
How has your market changed over the last few years?
The market for virtual server. Well, virtual server in 2005 is a revision 1 application.
Okay.
It's the first time it's ever released. So the market has gone from nothing to to what we have today. There's a lot of interest in it. Various companies are using it for various key scenarios. A lot of people are using it for we have, I would say, 2 main markets that we focus on. One is consolidation of workloads. So that's the scenario where you've got a whole bunch of NT4 machines lying around that aren't using much of their CPU, and you want to consolidate those into one machine. A lot of companies are using it for that. They get varying returns on investment on that. You could get anywhere from two servers on one server, up to we've heard of people doing 10 servers on a single box. You can do more than that. We can have up to 64 virtual machines on a single server. But the number of virtual machines you can put onto a single server really depends on what the workload is going to be inside those virtual machines. It's not intended for high bandwidth, high performance kind of environments.
Right.
When I say it's not intended for that, the workload is just not suitable for that.
Yeah.
Then the other place where we see a lot of interest is in development and testing. I mean, some of the features that we have in virtual PC and virtual server, they're a tester's dream. I don't know if Ben talked about undo disks.
Oh yeah.
Yeah, undo disks
I believe so.
That's really cool stuff. The ability to just throw away all the changes that you made since you turned on the undo disk and just go back to where you were before. Wow, that's really cool.
Yep.
A lot of the test communities within Microsoft are very, very interested in that stuff, and we do a lot of our own testing inside virtual machines for our own product.
Interesting.
So like installation tests, for example,
Yeah.
we would do that inside a virtual machine because we can go back to that pristine state where we didn't have any of our stuff on the machine, before we actually started doing the testing.
Very cool. What's the hardest part of your job? Finding good people.
I would say that hiring is definitely the hardest part of my job right now.
Yeah. That's a common thing.
I have a lot of
across.
open positions at the moment. I'm in desperate need of testers. So yeah, that's probably the hardest part. Is probably what I spend most of my time focusing on at the moment. Is reading resumes, and interviewing people, and that kind of stuff. The second hardest part, I would say, would be planning for the future. Microsoft is a company where they always do this ambiguous thing. This is what we'd like to do. Tell us how we get there. I'm trying to figure out what the steps are in between A and B is sometimes a big challenge, especially when you don't necessarily know what the progress is going to be like. You've got to make some estimates on how fast we're going to go with development and that kind of stuff. And testing typically comes second in the game. You have to develop it and then you test it. And of course, we're trying to change that with things like extreme programming and stuff like that. Unit tests are developed in tandem with the actual product code and that kind of stuff. So things are getting better in that area, but it's still up to me and my leads to be able to work out what we think our schedule is going to be, and then obviously try to match that to the milestones and so on we're trying to meet.
Is your product being used a lot in education? I think it would be attractive there because you could set up a desktop for a student, and then when the student leaves, at the end of the semester, you can just delete their image or whatnot.
I don't know if any education institutions are using it like that. I could certainly see how it could be used in a lab or workshop kind of environment, and I've heard of customers doing that, not specifically education, but other customers who do training and that kind of thing.
It just makes so much sense there because you have a kid who comes in and completely changes around the machine. Well, if it's just an image, you delete the image and put a new one out, and boom,
they tend to do that for short-term kind of things, So if you're running a lab today and everybody's got to come in and do something, and then tomorrow you've got to run the same lab for the next group of students, they'll do that. I haven't heard of anybody trying to do it for more long-term, where a student gets given a virtual machine at the beginning of his semester and then he uses it for the entire semester, and at the end you trash it.
Interesting.
I haven't heard of anybody trying that. I don't see any reason why you couldn't. I mean, it sounds like a reasonable thing to do. It's going to be costly in terms of disk space. You're not going to be able to do that on your average dual-prop Dell HP machine. You're going to need to have some beefy hardware for that, especially on the storage side. But it's not an unreasonable thing to expect.
Yeah.
Of course, with virtualization, you're limited to the hardware that we virtualize. You can't add your own hardware. So if you're doing anything to do with hardware development or hardware, that kind of stuff, then you're going to run into problems with that.
Yeah, I'm just thinking like an English class.
Anybody who needs like a web browser and Word to write some document or something like that, it'd work out great for them.
Yeah. Why don't you give me a look?
Sure, why not?
Show me.
So
let me mess with my camera a little bit.
Sure.
All right.
So what we have here is this is the web interface that I was talking about. Let me just refresh this page. This is the web interface that I was talking about that is looking at the right-hand server, the bigger machine. That machine is a dual-proc Dell machine. It's got 2 gigs of memory and quite a bit of hard disk space. And what I'm running on there is I actually have 5 virtual machines. Well, I've got 6, but I've got 5 core virtual machines that are running on there. I have a domain controller, a DHCP server, a RIS server, and 2 routers. Let's swing over to the whiteboard for a second. Let me show you what I've really got there.
What we really want to see is what was on these whiteboards before I came in.
So in virtual machines, we have a concept of a virtual network. Okay, and you can imagine a virtual network is like a hub or a switch that you can plug virtual machines into. Okay, so on that virtual server, I have 2 virtual networks. Let's call them VNC1 and VNC2. I have a whole bunch of virtual machines, and the way those virtual machines are connected is I have 3 virtual machines on this side, 1 like this, and then actually, you know what? I have 3 virtual networks. I just remembered. VNC3. I have another one like that. Okay, so this is router 1. This is router 2. And then over here I've got the RIS server that I showed you, the Active Directory server, and the DHCP server. Okay. What we're running there is actually a fairly recent build of Virtual Server 2005 SP1. one of the features we've added is PXE support, the ability to remote boot a client machine and do what's called a PXE install, or a remote install of that machine. Previously in the RTM version of Virtual Server, there wasn't PXE support built into the virtual machine BIOS, so you had to use the remote boot floppy that comes with remote install to do a PXE boot, and that has complications. Now we've added PXE support directly into the BIOS of the virtual machine. So what I can do with that server is I can have clients connected to any one of these virtual networks. And hopefully the demo will work, because I only just recently changed my server. And I can boot a client off any one of these virtual networks, and say I'm booting this client, it will go through that virtual network, through this router, through this virtual network, through this router. It'll get a DHCP packet from the DHCP server. That'll all come back. It'll also come back through the same path and find the RIS server, and then it'll actually start doing an install of the operating system off this RIS server.
Wow.
The interesting part about this is all of this is completely self-contained within my host. There's no external networking here at all. There's not a single packet that's going to go out onto the wire. This is all internal. So I've set up a fairly complex network with 2 routers, 3 subnets, Active Directory, DHCP, RIS, all of that, plus clients, and I can boot them and make it all work, all on a dual proc 2 gig of RAM machine. So let's see if I can make it actually do what I say it can do. So let's just have a quick look at the Active Directory server as a starting point. And you're quite welcome to film me typing the password if you want, because this is all internal. Nobody can see this. It's all self-contained within the server, so you'll never get to this machine.
That's good.
This virtual machine. So
you test out security, huh?
Yeah, you could use it for that. So here's Active Directory, and for anybody who's watching this who's familiar with Active Directory, you can see the domain controllers. This is the machine that we're running on now. Here are the various computer machines. Those are my client machines. There's the DHCP server and the RIS server, and this is all running on Active Directory inside the machine. So I go back to the master status page. I can then go into the RIS server, and you missed it. Too slow. I think I turned this thing off last time I used it, so. And as you can see, the performance it's reasonable. I mean, we are running 6 machines on this one machine at the moment, so you're doing quite a bit of work. So let's see, let's go to command prompt, my favorite place to be. I do everything from the command line, by the way.
You're one of those kind of guys.
I'm one of those kind of guys. So here's my remote install directory, and I can go into setup and English and images. And over here I've got, 5 different images of various operating systems and so on. And then let's have a last look at one of the router machines. And what I'll actually do on the router is I'm going to start a network sniff as well, so we can go back and have a look at that afterwards. Not a powerful, let's call it. Of course, when you terminate the virtual service, that kills all the virtual machines. So it's almost as though somebody went and pulled the power cable out of each of those virtual machines at that time. So that's why you get a lot of these power down kind of things. So here's the routing and remote access configuration panel, and here I can see that my router's alive, and these are the network interfaces that I've got: subnet 1, subnet 2, and this should indicate what the routing policy is, how it's going to be routing and so on. You'll notice that I've also got the DHCP relay agent set here. Remote install uses DHCP packets to send information from one network to another network, and if you're going through a router, you have to relay that packet. So let's start a network sniff. Do you think everybody knows what a network sniff is? I'm going to basically capture all the packets, all the network packets that are flowing around on this network. And then I'm going to go back to the master status page. So you can see there's a little bit of traffic going on there, not very much. It's a fairly quiet network. And now I'm going to go along and I'm going to start up one of my client machines.
Okay.
And now I'm going to actually go into the interface for that. And if I'm lucky, So there's our PXE boot ROM. It's now trying to do that DHCP discover, and it happened very quickly, but there was an F12 prompt there to do a network boot. And now what it's doing is this is all being served up from that remote install server that we talked about. So I can log in here as the administrator of the domain. And I've been decided to do an automatic setup. And let's say, okay, we're going to install XP on this machine. Tell it to reformat the hard drive and tell it to go.
Oh, that's nice. It's in a web interface.
Yes, yes, that is pretty useful. So there you can see setup is now looking at this virtual hardware. It's inspecting the virtual hardware, and it's going to actually start doing the installation. And it installs just like any other real machine would install. The virtual machine does exactly the same, as I'm sure Ben told you.
Yep.
And if we go back to the router, I'm not sure which one I installed, but yeah, you can see here there's a whole lot of extra packets now. There's a whole lot of network traffic going on now, and that's because that client machine is now remote installing. So if I stop this and have a look at the packets, I should be able to filter this down to, let's disable all of those, add in DHCP. Oh, there's no frames to display. Okay, I'm obviously not sniffing on the right network, but normally what would happen there is I'd be able to see the DHCP packets and the response that the RIS server was giving to that client as it was trying to boot up. All of that F12 conversation would have been there. So let me show you some more of the features of the product. As you can see here, we've got these little graphs that show what the CPU utilization is of a particular virtual machine at any moment in time. What we can do as well is you can go to the resource allocation page, and this is another feature that differs from Virtual PC. In Virtual PC you can say, I want it all to run very quickly, or so in other words, I want all my virtual machines to have the priority, or I want all my host applications to have the priority. You have one or the other. In Virtual Server you can give a lot more granular control over that. So I can say that this RIS server should never have less than 50% of the CPU, but it should also never use more than 75% of the CPU. And when I say OK to that, this is the same little graph. There's two little bars there that tell us, where it is. Obviously, if it doesn't need 50% of the CPU, it's not going to use it. But if there was a lot of contention between the different virtual machines for CPU, this virtual machine would never get less than 50%.
That's really cool.
Yeah. So that works out pretty nice. What else can I show you here? I can show you how easy it is to create a virtual machine. That's pretty simple. You basically go along to the virtual machines create menu option, and that brings up this panel, which I can say, okay, I want a new virtual machine. Actually, Fred, I think I've used already. Let's use Greg. So that's the name of my virtual machine, and I want to give this thing, say, 384 megs of memory. You can do anything you want, so I'll give it 381 megs of memory. It doesn't have to be a set amount. And here I can go along and specify what type of virtual hard disk I want for this virtual machine. One of the features that's changed between the RTM version and the SP1 version is we've now added the ability to create SCSI on the fly. So this is now going to create a virtual SCSI disk that I'm actually going to host on a machine that only has IDE. Okay, so that machine only has IDE disks, and I'm actually going to create a SCSI disk on top of that.
Oh wow!
So it's
why would you want to do that?
Well, it allows you to do testing. It also gives us a slight performance benefit. Our SCSI device driver is faster than our IDE device driver, so we get some benefit there as well.
Interesting.
So the point here, though, is that you don't have, the underlying hardware doesn't have to be the same as what your virtual machine is. In fact, it isn't going to be the same. We're going to virtualize that hardware. So let's say I'm going to make it a SCSI, and here's where I would select where I would connect that virtual machine. So in the diagram that I showed you, I had those various subnets and the virtual networks.
Yep.
These are those virtual networks that I could connect it to. So I could go along and say, right, I'm going to connect this to subnet 2 and push create, and now I have a new virtual machine. And in here I can specify various pieces of hardware and so on that I want to include. one of the nice ones is if you go to SCSI adapters, so I can go along, I've got one SCSI adapter at the moment, virtual SCSI adapter. So I can go along, I can add another SCSI adapter and add another one and add another one. Now I've got 4 SCSI adapters in this machine. If I can just see past the camera and hit the OK button. Now if I go to hard disks and I tell it that I want to add a new virtual hard disk, here's the important part, is I can attach it to the primary IDE or the primary IDE connection 1, secondary, and then I get into the SCSI devices, and as you can see there's a whole lot of places where I could connect it from a SCSI perspective. Now virtual hard disks can be up to, SCSI virtual hard disks can be up to 2 terabytes in size, and we have 4 controllers with 7 connections each, which is a total of 28 connections. So we can have up to 56 terabytes of virtual hard disk space allocated to any particular virtual machine.
Wow.
That's excluding the 428 meg IDE drives, 28 gig IDE drives that we could assign to it as well. So we can have a lot of disk space assigned to a virtual machine.
Okay.
What else can I show you? So I was showing you all the different things that you could configure on the virtual machine. We talked about the SCSI stuff. There's CD-ROM drive. There's network adapters. You can have up to 4 network adapters per virtual machine, which allows me to do that routing exercise that I talked about there. I have 2 virtual networks, 2 virtual network cards in a virtual machine and do routing through it. I'm actually running Windows 2003 as my routing software, so I'm just using the standard routing software built into the OS.
What's the most bizarre thing you've seen done with either a virtual PC or a virtual server?
This.
This one?
Yeah, in terms of internal networks and so on, this is the most bizarre that I've seen. There are other groups around Microsoft that do far more complex arrangements, but it's not all internal. They're using virtual machines to hook up. They've got a lot of hosts and a lot of virtual machines, and they make a big collection of things. A big scenario, a big network arrangement. They're using that for the what are they called?
You can use this to test web services too, right?
Yes,
I mean, anything that different servers and then
anything that you can run inside a real machine, you should be able to run it inside a virtual machine, unless it's dependent on a specific piece of hardware that we don't virtualize.
Okay.
So, for example, tape backup. We don't virtualize any tape backup devices. If you wanted to test tape backup, well, you need to do that on your physical machine where you have your tape backup device. However, your virtual machines could be used as the client machines that you're going to back up. So if you want to test tape backup over a network, your virtual machine could have the data that you're trying to back up, and the host machine could have the physical device, and then the two could be connected via a virtual network, and you could do that. You could test that there.
Okay. Anything else that's cool or that people don't know about virtual server?
Well, I don't know what everybody knows about virtual server.
Probably not a lot. Channel 9 guys are
another place where
all over the place.
the Ben may have touched on slightly with virtual PC. I mean, this is in virtual PC as well as virtual server. Is differencing disks. Did he talk about differencing disks, or did he only talk about undo disks?
I think we talked about differencing disks. Can you explain what those are?
So with differencing disks, you can create whole chains of hard disk arrangements. Easiest to show in the diagram. So let's say, for argument's sake, I am a tester in the Office group. Okay, and I need to test various patches and so on and stuff like that, and I need to test Office on a wide range of different operating systems and operating system service levels and all that kind of stuff. So let's say my starting point is Windows XP. So I install a VHD file, a virtual hard disk, that has Windows XP on it. And now I know that I've got Windows XP SP1, SP2, and SP3, the development version that's only available internally, if there is such a thing. I'm not sure if there is. So we have our three requirements. We need SP1, we need SP2, and we need SP3. Okay, I can make these virtual hard disks all point back to this single parent. So if I create a virtual machine that's associated with this virtual hard disk, it automatically has XP on it. and then I would install SP1 on top of that, and now this virtual hard disk has SP1 on it. What this hard disk is storing is it's storing the difference between what I've just added and what's on the original. So if I now try to read from this virtual hard disk, I will try to read that sector from here first. If I can't find it here, it means I've never changed it since I originally installed it. So I'll go back to the parent and read it from the parent. When I write, I always write to the differencing disk. Okay? So now I've got this arrangement of all the different service pack levels. Now let's say I'm testing Office, and Office also has a bunch of different service pack levels. So now I can create another chain out here, and I can say this one's Office 2K, this one's Office 2K3, and this one's Office 2K3 SP1.
Yep.
Okay, and again, I can have 3 virtual machines associated with that. This is pretty cool because, you know, now let's say I'm doing SP1 and I want to test the impact of a particular patch. I can go here and I can assign QFE1 and QFE2, and now I have virtual machines tagged off the end of those. Once you've set up this whole arrangement, you can also say, okay, I want to now test QFE3. It's just come out. I want to see if it works. I want to try it out. So I make a new thing over here, install QFE3 on here, and if it works, great. If it doesn't work, I can just throw that away and I go back to where I was, and you know, now that QFE, everything that QFE did has all been removed. So there's no chance that when I want to test it again, that some other little piece has been left behind from the previous install that could mess up this install. It takes me back to that pristine state.
Got it.
I can also take this entire chain and merge it all back into a new VHD that will then be XP with SP1 with Office 2K3 SP1 with QFE3. And now I've got a single virtual hard drive. And
What does QFE stand for again?
It's a quick fix engineering.
Okay.
And now I've got a new virtual hard disk that I can start creating a new chain of. It's a very complex arrangement, but if you sit down and plan your testing properly, you can make use of these features to do a lot of different kinds of testing, and it saves testers a lot of time. I mean, before, to do this, you'd have machines lying around representing all these things, and you'd have ghost images or some other kind of imaging format that you'd need to, you know, when you tested this thing and it didn't work and it blew the machine up, you'd start again. You'd go and get that image off CD or DVD or wherever it happened to be, and you'd have to roll it back onto the machine, and 2 hours or 3 hours later you'd have your machine back again and you could try the next fix. This makes it a lot easier. Just throw it away and it's virtual. Just throw it away, start again.
I love it.
Yeah, no, we love it too. Hang on.
Very cool.
Yeah, so that's what virtual server is all about. There's one other thing I want to show you here.
Okay.
Let's see if I can remember where it is. So, documents, request. Okay, this one. So this is a PowerPoint slide deck that I created that has a. Problem is, I don't know how good the resolution is going to work on this.
It looks good.
Okay, so this is in a smaller resolution than what I allowed for. But this window that you're looking at here is a live virtual machine. Whoops, you know, backspace doesn't do what I expected it to do. There we go. So this is a live virtual machine, but the point with this is you're actually looking at this inside a PowerPoint slide. I embedded our ActiveX control that gives you a view onto the virtual machine inside a PowerPoint slide.
Oh, that's really cool.
So if I end the, well, not end it, but if I switch out of this application and go back to the web browser that I was using before, there is the same virtual machine. So if I go in here and I type AAA and then go back to my PowerPoint slide, that one, there's the AAA that I just typed in the other window.
Wow.
So yeah, it's exactly the same thing. It's just another view of that same virtual machine.
Interactive PowerPoint.
Inside PowerPoint.
Yeah.
Okay.
Somebody else could be logged in there and be controlling your PowerPoint. And
Yes, they could.
awesome.
So the other thing that I can do
I see all
is
sorts of reasons to use
I
this.
can write scripts that I can link to buttons inside PowerPoint that do various actions. So, for example, I just did a save state, which is very similar to a hibernate. That actually looks like this part is something that I needed to test before I showed it to you. Let's do this one instead. Let's do turn off.
All right.
So there, I turned the virtual machine off. So that demo server that I was using is turning off.
Yep.
And in a little bit, it'll change. Oh, I've got to be inside this window. Okay, now it's off. Now the way that happened is, let me end this slideshow. Told you I was into the command line, so.
Have you seen Monad yet?
Have I seen what?
Monad? The
No.
new scripting? For the
No, I haven't had a look at that yet.
See
So-
the video on Channel 9 for that.
So here are the VBS scripts that I used to link to those PowerPoint buttons.
Yeah.
So one of the scripts to start up a virtual machine, for example, it looks like that, and it's really simple. The first two lines are just merely getting the name of the server that I want to connect to off the command line, and then creating a virtual server application object using that server name. Then I can use a function, one of the APIs that we provide, to find a virtual machine with the second command line argument, and then I just call that virtual machine and tell it to start up. That's another huge difference between virtual PC and virtual server, is we have a very extensive COM API interface into virtual server. There's over 400 different APIs that you could call. Anything that you can do with virtual server from a product perspective, what we ship in the box, you could write your own application to do that using a COM API, and you can write to that with C#, C++, command line, VBS kind of stuff. It's very, very powerful.
Very cool.
You can build your own interface. What I demonstrated there in PowerPoint could be considered let's say I only needed an interface that could start a machine, shut it down, and save state it. I could build that into a PowerPoint slide and I'd have it. So Lecturer, to go back to your example of, could you use this for a classroom kind of environment? A lecturer could build that in a PowerPoint slide with relative ease. I mean, it's not a very complicated operation. And send it out, and it's just a PowerPoint slide. It doesn't.
How did you embed it in the PowerPoint? Is it just a?
There's an option in PowerPoint to where you select various things that you want to put into your slide, like a picture or something like that. Well, there's one for an ActiveX control. You just insert an ActiveX control, and our ActiveX control is on the machine. You have to have the ActiveX control on the machine, but it's there, and you just select it and put it in and size it and tell it where it's going to connect to, and it's done.
How well does it work over the internet?
It should work fine over the internet. I mean, it's just an IP communication. Obviously, a lot of companies have things like firewalls and stuff in the way. We've got to make sure that all the ports are open all the way through.
Okay.
But that's documented.
I'm just thinking about it. How risky is it to use it at a conference or something?
The communication is secure. It's using a protocol called VMRC, which has security enhancements on top of it. Now, we also make recommendations for people to use SSL and all those kinds of things on top of that. We support SSL for both our ActiveX control and for our web interface. I don't know if you noticed, but on the web browser, it says here, warning, SSL security not enabled for this VMRC connection. And then lower down it says SSL not enabled for the virtual server administration website. If I had certificates and so on, I could enable the SSL communication, and then it would become as secure as SSL is. So I don't see.
What's the performance like over the internet? Does it stay pretty much the same?
It's pretty low bandwidth. It's not as low as something like terminal services. Okay. We're a little fatter than that, but it's not a fat client. We have optimizations in there to make things a lot faster.
Awesome.
Yeah.
Thanks for showing this to me. It's really
Sure.
cool stuff.
Pleasure.